Good morning, good evening, wherever you are. Welcome to our third training session related to our Transatlantic AI Hackathon. The German-American Business Association is happy to present the hackathon on health and safety monitoring together with EIT Digital and with Intel and Luxonis, our platinum sponsors, who do this valuable training leading up to the hackathon right now. I'm Michaela Balek, GABA's Executive Director. Today, we will hear from Jason Burris from Intel, this time about the OpenVINO Toolkit and the OpenModelZoo that power the inference you will be able to use with your Luxonis DepthAI device or any other Intel-based platform in the future. And yes, you hear that right. All Transatlantic AI Hackathon participants will receive the Luxonis Spatial AI camera board, provided your project gets admitted and you will be part of one of the 15 teams. So something to really look forward to, as well as this training session. Jay is always doing a wonderful job. So without further ado, Jay, why don't you get started?
Thank you, Michaela. Hello, everyone. I'm Jay Burris, and we've got Eric Kokaj as well. I want to say hi, Eric.
Hello, everyone.
We're here again, third webinar. Super excited about this upcoming hackathon near the end of September. I'm Jay Burris, and we've got Eric, who just introduced himself. So just as a reminder, so on July 28th, we have the first webinar available and recorded on demand. It was a high-level overview of the OpenVINO Toolkit, all the tools within the toolkit, but also up-leveled about what is AI inference, particularly as it relates to computer vision. On August 4th, Eric hosted the last webinar. It's also available on demand. He talked in depth about the Luxonis DepthAI cameras, about the DepthAI software. The cameras are powered by the Intel Mobilenet Myriad X vision processing unit, and how you could easily get started. Today, I'm going to go over a bit more as a refresher of OpenVINO, but really dive into OpenModelZoo and show you a couple demos, both with my laptop and with a Luxonis device. And then on August 18th, join us again for more demos using the Intel DevCloud for the edge, our cloud environment, which has OpenVINO installed, and you can do all the things that you could do on your laptop as well in the cloud environment. So we're coming to a little bit of a refresher, just to remind you. So OpenVINO is an AI inference toolkit. It's a toolkit to deploy computer vision models, speech recognition models, even regression models into devices either at the edge or the cloud, in fact. We're focusing here on the edge because we're focusing on a really low cost, easily usable device with this hackathon, which you see here in this image, the Luxonis. It's the OakD IoT 40. Now, OpenVINO's two core components are the model optimizer and the inference engine. The model optimizer's purpose is to take a trained model that you provide, and then you run it through the model optimizer to essentially convert the model into what we call the intermediate representation, a .bin and a .xml, which talks about the model topology and the weights and biases of that. It's so that the Intel architectures that you see to the far right can understand those models, because you can use models from a lot of different frameworks like TensorFlow and PyTorch and Onyx and Caffe and many, many, many more. You could train your own model in some other tool, maybe in the cloud somewhere at a service, maybe using some other capability that you have, but you can also use pre-trained models that we have. And that's largely what this webinar is about today, because it's about speeding up your capability of hacking when you get to the hackathon, because of course the hackathon is over a very short period of time. The model optimizer, it's a Python-based tool. Essentially, it imports the trained model, it converts it to this intermediate representation. It's hardware agnostic, as you can see, the hardware types on the far right. The inference engine is actually the code. It's sort of the suite of APIs that you build into an application. You can use C, C++, or Python to build it into maybe an application that does a set of larger things. You may want that application to be looking for input, such as having a camera, and it's maybe, I take the classic example that I did in my last webinar of a smart doorbell, where many people are now deploying smart doorbells, just have little cameras on them, and there's AI in them. It's trained to constantly look for people coming to the front door or going by even. And what it does is it infers and recognizes a person, and then it sends that data to the larger application that the inference engine is built into to essentially send the notification to somebody's phone through a cloud service. So it's interaction with an application that you define. Now, the supported frameworks I mentioned, there's lots of industry supported frameworks: TensorFlow, PyTorch, Onyx, Caffe, Quality for Speech and Language. There's just so many, and OpenVINO supports all of these. Now, the larger logos here are the ones that OpenVINO supports natively. You can convert a TensorFlow model into the inference, into the intermediate representation format, and run it with OpenVINO. And you can with all those other 5. The smaller logos are available through the Onyx exchange, the Open Neural Network Exchange. OpenVINO can run the intermediate representation file format as well as the Onyx format. You'll get better performance with the intermediate representation file format. But what you can do with these other frameworks, the smaller logo ones, is you might find a model, a trained model out in the Open Neural Network Exchange, the Onyx Exchange, and then you can convert it with the model optimizer in OpenVINO to the IR format, the intermediate representation, and run it with OpenVINO. So we've really allowed you the capability to run all sorts of different frameworks in a couple of different ways. PyTorch is also a very, very popular framework. I mentioned that. It's one of the smaller logos. So just use a PyTorch model and convert it to the Onyx framework, and then convert it to IR and run it with OpenVINO. Now, another really important thing that I stressed at my last webinar, 2 webinars ago, was there's a number of different sizes of models that are capable to run with Intel architectures. And this table defines that. So the first row is CPU. If you were to run a model on an Intel CPU, which you might have in your Intel-based laptop, which you would, you could run a size model of FP32, FP16, or Int8. Stands for floating point 32, floating point 16, or Int8. It's really a different size, and it's called quantization. Now, the device that you're going to use in the hackathon, this Luxonis OakD IoT40, specifically uses this really small, fast, performant, embedded chipset from Intel called the Mobilenet chipset. And you need to use the FP16. It specifically requires FP16. I'm going to talk today and show you and walk you around a bit of the OpenModelZoo and so forth. But you can, in many of our pre-trained models, have available already both versions of an FP16 or an FP32. Just remember, you want to use the FP16. You can use the model optimizer to convert an FP32 to an FP16 as well. That's kind of what this command down here states. This is actually a Linux command, but you can do this in Windows. And it's using, in particular, the mo.py Python command, model optimizer. It's stating that it's doing this on a ResNet 50 Caffe model, and the data type of FP16 specified. Now let's talk a bit about the OpenModelZoo, because that's really what we're here to talk about today. So the OpenModelZoo is a set of pre-trained models, as well as demo applications, and a couple of tools. There's additional tools available with OpenVINO, which I'll talk about as well as we go through walkthrough of the directory structure. There are two sort of types of pre-trained models. There's the Intel pre-trained models, and then there's public pre-trained models that we make available, and they're all on GitHub. The demo applications are sort of larger applications where you can see all the code written in C, C++, or Python that may use a pre-trained model. And so that demo application kind of will give you a roadmap of how to write an application yourself. Lots of different pre-trained models are available. In the Intel pre-trained models, there's things for object detection, re-identification, segmentation. This image here on the far right is sort of an example of a segmentation. Human pose estimation. I'm going to show you that demo today, and it's pretty cool. Text detection and recognition and others. There's public pre-trained models, which we've sourced from public sources that do classification, segmentation, object detection, many similar things, but models that were developed out in the public by researchers. Lots of them, say, at Cornell and other institutions who have developed these models. The demo applications are, I said, are these sort of full applications that have the inference engine API structure built into them and a selected model and a way to run the demo application. And I've only highlighted the green one because it's the human pose estimation demo that I'm going to show you today. Again, all available on GitHub, so really easy to access. And there's also a really easy tool to use, a model downloader tool. You can use the model downloader tool to do like a -H for help, so you can get the arguments. You can use the model downloader tool to print all the available models. There's a number of ways of doing this. And then also there's an accuracy checker if you were curious. So if you want to check the accuracy of the original model versus after you've converted it to the intermediate representation format, you can do so. And you can see how little accuracy has changed by converting it. Maybe you want to convert a model from FP32 to FP16. Why would you do that? Well, number one, as I stressed already, you'll want to use the FP16 quantization models with the device that you get as part of the hackathon. But FP16 models also are smaller and run faster. But to do that, they may sacrifice on a little bit of accuracy. Now, as I mentioned in my last webinar, there's a whole host of Jupyter Notebook tutorials that you can get started. I'm going to start with one in particular, the model optimization and inference engine tools. So for the sake of speed, I've already started this OpenVINO Jupyter Notebook. But to understand how to get started with these, let's see if I find the right window. Yes, here it is. So the OpenVINO notebooks that I was mentioning are all available here. You can see the Hello World, you can see the one on OpenVINO API, Hello Segmentation, and so forth. There's one down here called the Model Tools. Now, to get started, there's some instructions here on an installation guide. You can do this for Windows, Ubuntu, and many other OSs. And it kind of specifies whether you're using with Linux or with Windows. This is a very easy setup in Windows. So essentially at a command prompt, you can essentially, you're doing a sort of a smaller install of OpenVINO. I still recommend doing a full install of OpenVINO, but you can do a smaller install of OpenVINO in this method, and it kind of makes these notebooks available to you as well. So you go through these commands, setting up your environment, you're cloning the Git OpenVINO notebooks, you're going into that directory, and then you want to sort of install the requirements for this and the kernel, and then you just launch a Jupyter Notebook with Jupyter Notebook and then specify the notebook that you want to start. Now, you just do this at a command prompt, and I've already started it. And here is what it looks like. Now, this is a really easy way to also do some of the things you might want to do with OpenVINO, which you can do on the command line, but sort of it's already structured in the Jupyter format locally on your PC to be able to do this. Now, the first thing here is you just specify a model name that you want to eventually download. And you can see I've commented out several examples, but I have uncommented human pose estimation. I'm just going to run it. So it's just set that argument for model name. Now I'm going to run some imports of common libraries for Python. And then this section is really also setting up some arguments, such as where your base model directory is and your cache directory. You're setting the precision to FP16. You're also instantiating an inference engine. And then it's just checking if GPU is available. So you see it's set it. Here's the directory at which it's set. So my users, JM Burris, OpenVINO ModelZoo models directory. Now in this section, you could actually run some things if you wanted to get some help. So at the top, there was a list of these kind of 4 tools available in the OpenModelZoo tools, Jupyter Notebook. So you could run this help. You could uncomment this if you wanted to for downloader, and then it'll print out all the arguments for you. I'm going to recomment that back. Let's say you wanted to get info on all the available models. So with this command, I'm actually just going to dump the info and print all. And so now what it did was it printed a whole list of all of the available models that you could actually download. So you can see human pose estimation. This is the model that I'm downloading, but see all of these different models. So if you went back up to the top where you set the model argument, you could just choose another one of these in there. And then eventually, when you come down a little further, this is the download command. And so what it's doing is it's running the OMZ downloader. It's specifying the name that you used in the argument at the top. It's specifying an output directory and just a cache directory. So I'm going to run it. And now it is downloading the human pose estimation 0001 model. And you can see it downloaded. See, there's the XML and there's the bin. It actually downloaded FP32 and FP16 versions and the FP16 int8. I will only be using this FP16 version today. Okay, the rest of this is about converting the model. Now, it's already converted. This particular model, our Intel pre-trained models come already converted. The public models don't. So if you downloaded a public model, you could use this section to convert it. So just for the sake of doing it, I'm actually going to convert it. And it just says skipping, no conversions defined because it's already defined. Now there's a little bit more information in this Jupyter Notebook tutorial. You wanted to get more information about this model. So some code that's written essentially using the OMZ info dumper. I already kind of showed you that above for doing a full list. But in this case, it'll run it specifically on the model that I just downloaded, the human pose estimation. And so it's telling you that it's a 2D human pose estimation with a tuned MobileNet backbone. It requires the OpenPose format. There's actually 3 other human pose estimation models, and they require a different format. Why are there 4 different ones? Well, One's TensorFlow and one's PyTorch. I think one's Caffe. So there's just different versions from different frameworks available. And this will just run and essentially set some paths, and it tells you that the path for this model, it exists and it's at this location, user Chamberis, OpenModelZoo models. So if I were to go to a directory structure, see if I can find the right one. Just open a new one. And go to users, Chamberis, OpenModelZoo models. It's created a directory for Intel and public, and this is an Intel pre-trained model. And so you see there's human pose estimation. I previously downloaded the other three as well, but in here, you'll see directory structures for all three of those quantization size models. And in the FB16, you see it downloaded the .bin and the .xml. Okay, and then there's some additional commentary and things you could do with the benchmark app, and I won't go through the benchmark app today. Okay, so now we have our OpenModelZoo model. Now, if you wanted to find out more information on this particular model, you could also go out to a GitHub location for this. So the OpenModelZoo Repository, you can see, contains the Intel pre-trained models and the public models, as well as information on the tools that you can use. So if I went to here, Intel pre-trained models, you'll find a whole list of all of those models that, remember, I printed out, but I'm going to look for the human pose one, and it's under a section called human pose estimation. So if I go into here, this gives you a high-level overview of the model, kind of what we just printed out on the command line. It tells you a bit about, there's 18 key points, ears, eyes, nose, neck, shoulders, and you can kind of see in this image how it eventually displays. Now, this is all interesting detail about a model, and all models will really talk about this, the inputs of what the model expects. So it expects a batch size of 1. It expects 3 channels, so BRG. So some models are trained in RBG, red, green, blue. This is trained in blue, green, red, and the size. So number of channels is essentially RGB, BGR, and then the size of the model. So that's what this BCHW stands for. Your model, you might actually have to use OpenCV, which we talked about in my previous webinar, of how you can reshape and transpose your image so that it's in the format that your model expects. Okay. Now, I am going to run this model. So now, I've actually built the OpenModelZoo, the demo application. And why don't I show you where that is? Okay, so when you do a full install of OpenVINO, let's get to the top here. A full install of OpenVINO is going to be installed in your program files, and then an Intel directory, and then OpenVINO. And this, I've installed the latest, which is 2021.4. And this is really just a redirect. So either way works. And this is the directory structure for OpenVINO. You get a bin, which actually hosts an executable to just set up your environment in a command line. You get deployment tools, so things for the inference engine, demos. These are some initial demos. When you do the install of OpenVINO, through the installation instructions, we supply this because you'll run a couple of these demos, this security demo security barrier camera demo and this SqueezeNet demo, just to confirm that you have fully installed OpenVINO and everything's working all right. There's the Intel models available as well. Model Optimizer. So these are the tools to run the Model Optimizer in command line with a full install of OpenVINO. And then OpenModelZoo. OpenModelZoo here you can see is you also have models and you have demos. So in the demos folder, you'll see all of these demos and directory structures. Human pose estimation is the one we're going to look at. So in here, you can see that there is the source code for either C or Python. And so you could actually, if you wanted to open up the C++ file, you can see all the source code. The model list tells you the models that can be run with this particular model. So I'm just going to open this up in Visual Studio. And you can see it'll take human pose estimation 001 as well as 005, 6, and 7. And the README on this will just tell you a little bit more about this particular application. So I'll just open in a notepad. And so you can see, and every demo application has files like this, tells you how it works, tells you setup, talks about how to download and use the model list to download the appropriate, again, 0001, 5, 6, or 7 for this particular executable. Okay, now demos are built with an application called Build Demos MSVC.bat. It's a little bit different on Linux, just some different naming nomenclature, but this is all available on either way. And you run this, and it will actually build all of these applications for you. You can do a -H help to find out what the arguments are. The output of that ends up being in a folder which you can specify, but in this case, I've built it into a folder called my documents folder, Intel OpenVINO OMZ demos build, Intel 64, and release. So if we do a dir human star, you'll see that there's a human pose estimation exe demo here. Now, if I want to execute this, the command to do so, described in that README, is to really start with the exe. It specifies in the arguments that you have to specify the format for the model that you're using, in this case, OpenPose, so -AT OpenPose. The -M specifies the location of your human pose estimation.xml file, the model, and -I is specified to a file. Maybe you recorded a file, a little video file, and which I did. I recorded a file which is called video.move. I just did it on my my iPhone, and I will try to start it now. Okay, last night I recorded this demo just of me on my iPhone, and you can see it's mapping my human pose. When you think about these types of models, and for the health and safety hackathon that we're doing, for instance, this could be used in say predicting movement of maybe the elderly or disabled to help them to maybe identify a risk of falls. Okay, so that's that particular demo. Now, all of these other Jupyter notebooks are really, really valuable. So you can also start the Hello World one. Simple Python runs basic inference with a MobileNet v3. The next one over, the OpenVINO API, really breaks down the structure of how to use OpenVINO and the APIs. This TensorFlow and this PyTorch is a demonstration of how to use the converter tools to convert a model to the intermediate representation format from TensorFlow to IR or PyTorch to OpenVINO IR, and then several other OpenVINO Jupyter notebooks. You can find these on GitHub. You can just very easily Google OpenVINO Jupyter notebooks and you'll find it. So I've already shown you the human pose estimation demo. I hope you found it to be pretty cool. Now I'd like to show a little bit about the Luxonis as well. Okay, so hide my meeting controls. Now, Luxonis devices are even easier to get going with. Now, they have a you can go to docs.luxonis.com to find the DepthAI documentation, and if you can still see me on camera, I'm actually using one of their devices. This is the OakD device. They have several other versions. A different version that you'll get though is this particular device, this really small device. It has all the capability of the OakD that I have plugged into my PC, but it also has, it can run standalone, so you don't have to plug it into a host computer all the time. But in here, getting started is super easy. You can watch this simple tutorial video, but it's equally as easy to get started with this. So there's a download script to get started. So you can go to the command line and you can clone the DepthAI Git cd, change directory into DepthAI, and you can create, it's optional, a Python virtual environment, and then you can run this command to install the requirements for the packages. And then the next step is you can get started with the demo. So for the purposes of speed, I've already done all the git cloning and the install, just those simple instructions. And I did it at a place called, in my directory, called OakD, and then DepthAI. So the DepthAI Git is cloned to here. And if you were to look in this directory, you can see all the files and different Python tools available. But to run the demo application on Windows, it's not a Python 3, it's just a Python. And you can start out with this very simple command that was on this previous page. Let's see if I can find it. Right there. So I'm going to run that command. Oh, that's because I had to unplug it for my audio. Okay, now I've plugged it in, eliminating the USB hub. All right, and it started. Very, very simple to use. You can see two screens came up. You can see me. This is me here in my house, here in my kitchen. And the other window is really the depth capability captured by this. So that's me in depth sensing. Now, if you wanted to try some of the other things, going to this directory, they also have a number of available other models available. But you could also continue on in this instruction. You could essentially use cam left. It would show you a grayscale version of yourself. You could use cam right as well. And then there's some other default models that they have available. So you could run this face detection retail model, and they have below here a whole list of other ones. So let's just try the MobileNet SSD. So same command as before. And whereas I didn't specify any arguments, I'm going to go -CNN, which is presumably for convolutional neural network, and then specify MobileNet SSD, which is MobileNet-SSD. And once again, it brings up two very similar screens. But this model detects a person, but it also can detect a bottle. And it's trained on 20 different classes. Eric, do you happen to know which classes it's trained to detect?
Well, I can quickly check. I just wanted to mention that by default, if you don't specify the convolutional neural network, it will use MobileNet actually.
Oh, okay.
So it's the same as specifying MobileNet. Let me check which classes are those.
Okay. Alrighty. So moving on, I want to remind you, also check out our Intel DevCloud for the Edge. I mentioned this in the last webinar I hosted. So, you can do OpenVINO in a number of different ways. You can use it on your local PC, and I do recommend that. You can also use the Intel DevCloud for the Edge, which has OpenVINO pre-installed on it. It's instant access. It's free to access. So you don't have to budget for anything related to hardware in particular to test things out. You can learn OpenVINO from Jupyter Notebooks that are also available there. So notice I was showing you Jupyter Notebooks available on GitHub. We also have Jupyter Notebooks instrumented in the DevCloud. You get up to 50 gigs of private storage space. So, if you wanted to upload your own videos or images, you can do that. And there's also other capabilities in the DevCloud where you can benchmark like frames per second and performance of a model. And how it works is a user logs in and they essentially connect to development servers. These are running Xeon, but it's really the host servers for the whole environment, for what the environment looks like, and for your 50 gigs of storage space as well. And it hosts the Jupyter Notebook sort of environment, so you can start your own Jupyter Notebook or use the Jupyter Notebook tutorials that are there. But you can code in your own Jupyter Notebook there, and then you can execute a job to a queue and specify different hardware that's actually physically in the cloud. So you could execute it to CPU, different SKUs of CPUs. If you wanted to compare the performance to different GPUs, so integrated GPUs inside of a CPU, and also VPUs. We have Intel Neural Compute Sticks out there, as well as some other PCI Express devices slotted into equipment that make VPUs available. And then you can really do much the same as you would on your own laptop.
So Jay, I just checked out the MobileNet labels that you asked.
Yes.
So the default MobileNet, the 20 class, is trained on airplanes, bicycles, birds, boats, bottles, buses, cars, cats, chairs, cows, dining tables, dogs, horses, motorbikes, persons, people, potted plants, sheep, sofa, trains, and TV monitors. So these are the classes that the default pre-trained MobileNet SSD will detect.
Right. So that's just one example of a model. There's all those like 200 plus models, the Intel pre-trained and the public trained ones. They're also, many of them are, they're trained for people recognition, vehicles, license plates, all sorts of classification models, some of them trained on 1,000 different types of objects. So resources and community support. This will obviously be available in the video. We're posting the PDFs as well, so all the links are available to you. My last webinar has this content, but I'm just reminding you. The availability of pre-trained models, sort of in that qualify stage. Start with a pre-trained model. It's the easiest way to get going. In installation, there's a number of ways to install. I do recommend installing directly OpenVINO to your computer. And you can essentially move on to the prepare stage where you'll really start to experience some of the demos, so that sample applications, like I showed you the human pose estimation one, and you can start to understand the flow of the inference engine workflow, and then you can get hands-on. And then for support, we have a community support forum, but we also do have a Slack channel specifically for the hackathon that we will be monitoring. If you're curious about maybe a little bit more in-depth training, we have an Edge AI certification program. The courses are actually free, so you can go through all the courses. There is a $99 fee to acquire the badge if you want to do that, but it's not required. But you can do that if you think that it will enhance your resume. So I do recommend considering this. But at the very least, all those courses are free, and so you could also sort of upskill yourself. You can learn a bit deeper about the inference engine, the model optimizer, OpenModelZoo's, DevCloud, and there are 3 learning paths with Jupyter Notebooks where you sort of get to play and experience. I remind you that we do have projects out on Intel Devmesh. So devmesh.intel.com. These are community-based projects, not just Intel developers. People who love AI, and there's all sorts of other types of projects besides AI, because they're using lots of tools from Intel beyond OpenVINO. But there's project ideas out there that you could consider looking into. And of course, if you're a student dialing in and you're curious about and interested in becoming an evangelist for Intel, we have the Intel Student Ambassador Program. Visit us. The easiest place to find sort of the landing point for Intel stuff is software.intel.com/IoT. So you want to explore reference implementations. It'll also sort of redirect you to GitHub where needed, but you'll find information there. You can download software, you can learn more, you can find access to the Intel Developer Cloud for the Edge, and you can also find access to the Edge AI certification program if you want to go through some of those courses. So great place to get started. So I am going to, we're almost done really. Your homework, and I added a 4th one from the last webinar. So your homework, try out our Intel DevCloud for the Edge is sort of the easiest, fastest way, because OpenVINO is already installed for you. So you don't have to install OpenVINO to sort of start getting going and trying out OpenVINO. So start with DevCloud for the Edge, then download OpenVINO directly from Intel. You can use Linux or Windows, and then also try out the Jupyter Notebooks. Those are available on GitHub. It also instructs you on how to install a smaller OpenVINO developer environment to be able to use that. And you can install both on your PC. And lastly, but not least, I recommend checking out Luxonis DepthAI documentation. That's what I showed you today, how easy it is to get going. I think it was basically 4 commands once you get the device in hand to clone the DepthAI Git repository, set up your environment, install, and then execute your first demos. And lastly, reminder, please join us again next week. I'll go through more demos, but this time in the DevCloud for the Edge. So I'm really excited for the hackathon coming, and to see what you all devise and create in terms of helping in terms of solutions for health and safety. And really, it's about how can we reimagine how people and data can change our world for the better. So with that, we can go to questions. Michaela or even Eric.
Wow, yeah, this is great, Jay. I really like the demos, and of course what these tools can do, and apparently you can get to use them in such a short amount of time. I mean, that's really amazing. Thank you. So yeah, to the audience, if you have any questions, please put them into the chat box, or you can also raise your hand and we can put you live and you can ask them directly if that's easier for you. So either way works. And in the meantime, as I had indicated in the chat, you can watch the previous training sessions. You can find them through transatlantic.ai/hackathon. And you get several links that are important, including registration for the hackathon, registration for the last training as well, if you want to forward that to your friends and future teammates anytime. And yeah, just remember, you can win a total of 10,000 in prize money on this hackathon, health and safety monitoring. And as we had mentioned before, all participants will receive the Luxonis Spatial AI camera board. Once you're in one of the teams and get going on that weekend, you will actually receive that board beforehand, so you can familiarize yourself with it and actually can use it for the hackathon. So yeah, are there any questions or comments?
I just want to remind you, so our 2 on-demand webinars are available. So the first one here and the second one was Eric and really focusing on the Luxonis device. And then you can see the recording is available as well as the slides. So we realize that there's hyperlinks in a lot of the slides, so you can download the slides and go to all those links.
Yep, that's exactly it. And we will put this one, of course, then also on there, and the slides as well, I assume.
Absolutely.
Well, it looks like you did a fantastic job, Jay. There are no more questions at this point in time. Maybe they come later once people start working with these tools.
Yeah, so I would say use the Slack channel to communicate. It's almost maybe even a better place to communicate because it's the question and answers get recorded. Yeah, excited, looking forward to this hackathon.
Yeah, same here. Thank you so much, Jay and Eric, and everyone in the audience. Good luck. And yeah, let's get going on this. It's very exciting. Take care, everyone.
Absolutely. Thank you.